Okay, so for 12b, we're looking for the midpoints, the sides of a rectangle, the vertices, of a rhombus. So let's have a look at a rectangle. Here's my rectangle. Let's make this A, we'll make that 0, 0. We'll make this B, 0B. C can then be AB and D can be A0. So we also would say, let vector A, so we can use it, be 0, 0, vector B be 0B, etc. C be AB and vector D be A0. So it's good to kind of say that, which I should have before in the other one. All right, and then we're interested in the midpoints, so we could call that M again, and N and P and Q, the midpoints, and have a look at them first and then show that they're the vertices of a rhombus. Okay, so let's have a look. So what would OM be? The midpoint M. So we're taking OA and we're adding half of AB because it's the midpoint. So we're going to get 0, 0 plus half of 0B. So we're going to get 0 half B for that one. All right, let's look at ON as well. So ON, again, I'll go OB plus half BC. So OB being 0B, and then I've got half of BC, take C, which is AB, and minus B, which is 0B, and we are going to get half AB. All right, we also want OP, so OP we would do OC plus half CD. So OC is AB and half of CD. So D is AO and we're taking C, which is AB. So we're going to end up with an A and a half B for that one. And we need OQ. So OQ being OA, which is our 0, 0, plus half of our AD. So we want half of D, because A is 0, so that's a nice easy one, so that's half A is 0. So 0, of course. All right, so now let's have a look at the sides of this so-called rhombus. So we're going to have MN is one of the sides, and so N is half AB, and we're going to minus M, which is 0 half B. So that is going to give us half A, half B. And then if I look at QP, so MN and QP should be both parallel and the same length, so they should be the same vector. So we get A half B, and we're subtracting half A, 0. So we do get half A, half B again. So we know that MN equals QP, they're the same vector, so parallel and same length. Nice, so we know that so far. Now NP, so hopefully you've got these down so I can use this area here. So NP, let's have a look at that one. Come on, pen. Here we go, it's a bit slow. NP being P minus N. So we should have half A, negative half B there. And MQ should be the same vector. So we've got half A, 0, and we're minusing 0 and half B. So we do get half A minus half B. So again, these two NP equals MQ. So they're also parallel, the same direction, same length. So that's all great. So that would be a parallelogram, but we want a rhombus. So we have to show that the sides are equal. So we have to look at one of these. So let's say NP, and one of these. Let's take that and make sure those sides are equal. If that's equal, then of course the other two are equal as well. So let's find MN's length, which would be the square root of a half which makes a quarter. Oops, why did that happen? So I've got a quarter a squared plus a quarter b squared, and if I take np and find the length there, I've also got a quarter a squared plus a quarter b squared. So then we can say, all right, so all sides are equal and parallel, and there's two parallel pairs of sides. So they're equal length. So then we've got a rhombus. So just make sure we've covered that as well. Otherwise, it's just a parallelogram. So we need to show that the sides are also all equal length.